Alright, this is Mr. Gillum, and today we're going to learn about truth tables. And basically what we're going to do is we're going to make some charts, kind of like a Punnett square almost, basically telling us whether something is truthful or not, whether it has a truth value or not. And mostly we're going to be looking at compound statements today. So let's take a look here. And our truth values here, our truth tables, well, let's just start with negation. Basically what I'm going to do here is I'm going to just start with the variable p, or my statement P. There we go. The statement P, and I'm going to decide there's two things that can happen with statement P. Either it can be true or it can be false. Now, not P, on the other hand, has, let's do a different color than that. Not P, on the other hand, would be exactly not what P is. It sounded really confusing, but in other words, if we're comparing not P to P, if this P is true, then not P would be false. Or if P is false, not P would be true. Okay, so that's our very infancy, elementary, basic truth table, comparing a statement to its inverse. Okay, now let's look at conjunction. So if I just had P, that would be an example. Let's look at its conjunction. So if we said P and Q, if we said P and Q, first of all, we have two variables now. So what's going to happen is the size of our chart is going to double. So we're going to have twice as many right down here. 1, 2, 3, 4. Before we only had 2. We're going to have twice as many columns. And what I'm going to do strategically is I need to make sure I have all of the possible things that could happen represented here. So to do that, what I'm going to do is I'm going to start with my first statement, my P statement. I'm going to do half of the values true as half the values false. So true, true, false, false. And what I'm going to do with Q is I'm going to alternate them, true, false, and that will give me a representation of all the different things that could happen. Okay, you won't see any repeated parts on this particular example. True, 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 false, false, true, false, false. So 4 different things that could happen. Now with an AND statement, we know from our practice that both of the statements must be true. So in this case, we have a true and a true. If we're talking about P and Q, they both have to be true. If you see even one false, it is a false statement. So because they are both true in this guy, if both statements are true, then P and Q must be true. If, just used a conditional there, if P is true and Q is false, as long as there's one false, then P and Q will be false. Same way here, if you see a false, and we're talking about an AND statement, they both must be true to be true. So in this case, if one of them is false, the statement itself, the conjunction, is false as well. False, false, false. Okay, so you'll actually have to fill out these tables. I'm just writing over them right now because I want to make sure you have them in there exactly the way they need to be. Let's take a look here at a disjunction, an OR. Now an OR, P or Q, an OR statement, as long as one part of it is true, then its truth value is true. And we've been practicing that as well. So once again, I need, since I have 2 variables, I really need to have 4 rows. If I had 3 variables, 8 rows. If I had 4 variables, 16 rows. And they can get really, really long. But today I don't think they're going to get too more complex than 3 variables. We're going to do one of those here in a second. But since I have 2 variables, the first variable I shall label half trues, half falses. So true, true, false, false. My Q variable, now, or my Q statement, I should say, I want to alternate because I want all the different possible things that could happen. I could go true, 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 false, false, true, false, false. Now, I still have the same amount of trues and falses in each column. I just put them in a different order to line up with each corresponding possibility. Now, in an OR statement, it's a little different than an AND statement. In an OR statement, as long as one part is true, then the statement itself is true. The disjunction is true. True, false. As long as one of them is true, it's true. False, true. Oh, we have a true part, so that's true. And false, false. So neither of them is true. Then and only then will it be false. Both of them are false. So looking at this, you can see we got 1 true and 3 false over here on this guy, this conjunction, and we got 3 trues and 1 false on the disjunction, which makes more sense because OR statements have a more tendency to be true because it only takes one part, not both parts of the disjunction to be true to make the statement itself true. Okay, so as we add variables, the size of the table doubles. 3 variables, we're going to have 8 columns, 4 variables, 16 columns, and so on and so on. So let's just do this here, and I only put 2 on here because I don't want to waste half an hour of your time. I want to give these 2 thorough examples, and then in class we're going to do a couple more before you get started. So right now what we're going to do is this. I'm going to say what I notice here is I have, and what I would like to have done, I'm going to actually change this. I'm going to make this guy right here. I'm going to change this up a little bit. I'm going to make him Q right there, and I'm going to make him not P right here. I'm going to look at each part of this. In this case, it is a disjunction, an OR statement. I'm going to look at each part of this, and I see 2 variables. So I'm going to start with my P and my Q as my first 2 parts of my column. I know that this is one part of my disjunction, the not P, so I need to somehow account for that in there. So there's my not P. And finally, once I have my not P and a Q column, I can make my final not P or Q column, and I can determine its truthfulness regardless of what the statements are, as long as I can determine their truth values. So I have my 2 variables here, and I'm just going to go ahead and start filling out the chart. I want half truths, true, true, false, false. I'm going to go true, false, true, false. All right, and what that's going to do is that's going to give me every possible combination of each statement being true or false, and eventually going to give me my outcome as being true or false. My not P column I need because I'm comparing it or Q. I'm comparing it to Q in a disjunction. So for my not P, I'm going to simply look at P, and I know that if P is true, then not P would be false. Or P is true, not P is false, false true, false true. And so I'm almost done with my whole truth table. I just have to decide is not P or Q true or false. And like I said, depending on what the statements of P and Q are, it'll tell us. If we can determine their truthfulness, then we can determine whether or not P or Q is truthful or not. Well, what its truth value is. Okay, so we are looking just at the not P column, this guy right here, and we are also looking at the Q column. Those are the 2 columns we're comparing. And because we're using an OR statement right here, as long as one of them is true, the outcome is true. So because I see a true right there, I know that this must be true. I see 2 falses here. Okay, if both are false, then the OR statement would also be false. If I see a true, we're good. So that's true. And I see a false true here. As long as there is one true, there's a true. So in this particular OR statement, I have true, false, true, true. Okay, so depending on what P and Q, what their truthfulness is, P could be true and Q could be true. So there's all different these kinds of combinations that could happen. But the truth value for that specific OR statement, not P or Q, there's 3 chances that it'll be true, 1 chance that it'll be false. And like I said, it depends on what the statements are, will depend on which column you're looking at. So if I had a P statement that was true and a Q statement that was false, I would look at this guy right here. And so I would know that if I wanted to know if not P or Q was true or false, it would be false because it falls in the false category. Okay, so the truth table is going to help you determine whether your conjunction or disjunction is true or false, and it's just basically going to fast forward you through all the mess, hopefully. So, okay, so now we're getting complex quick here. You're in advanced geometry class. I know you can do it. Let's take a look at this truth table here. And I've already set up the columns up here, but I want to tell you where they all come from. I have a P variable, a Q variable, and an R variable. So that's where I'm going to start. Okay, but I have specific parts to my Q and my R, well, specifically my Q. I also have a not Q. Okay, so I also need a column for him. At the end of the day, I'm going to put a little dashed line here. I'm comparing P or the conjunction, not Q and R. So I also need to actually compare this whole thing, so I'll put a column in there for that, to P, and then finally my conclusion statement right here. I will know whether it is true or false depending on the truth value of P, Q, and R. So let's take a look here. And because we have 3 variables, you'll notice that I have 8 columns. I'm going to make half of them trues on the first and half of them false. And I might have misled you a little bit on the last. I'm not going to actually interchange like every other one for Q. I'm actually going to do, since I did 4 trues in a row, I'm only going to do 2 trues. False, false, true, true, false, false. And the reason I'm doing that is because I have this last variable in here, and that's the one I actually want to alternate on. And that's going to give me all 8 unique possible things that could happen. And if you look at all these columns, none are going to be exactly the same. They're all going to be a little different somehow. A true or a false differently, or some different combination. So that's why we have 8 columns, because we need to account for every different thing that could possibly happen. So if I have 4 variables, I'd have another additional, it would double again. It'd be 16 total, 8 more. But once we start with our basic, our foundation, one for each, we have a truth value for each variable and what could happen. We're going to go through and we're going to finish the rest of the chart here. So as I'm looking at this not Q column right here, all I need to do is compare the not Q column to the Q column. Whenever Q is false, whenever Q is true, not Q will be false. And whenever Q is false, not Q will be true. All right, so there we go. So that wasn't so bad. Just had to do the opposite of whatever Q was for not Q. Now I'm comparing not Q and R, so let's do a different color for that as well. Let's do that one. Hopefully that'll work. Not Q and R, so I'm comparing this guy, looking at the not Q column and the R column. Right there. And because I have a conjunction, an and statement, the only way for me to get a true value out of that is if they are both true. So I see a true here. So there's a true. I'm going to skip through and I see another true here. That must be a true. Okay. All the other ones have a false involved. This one has a false right here. So I know that an and statement would be false if part of it is false. This is a double false. That's definitely false. This has a false part. This has a false part. Remember, for and, both have to be true. False, and finally false. So we're getting closer to our actual comparison, which we're comparing P or not Q and R. Okay, so we're comparing that statement P in a disjunction with not Q and R. So now, finally, the last little part here, what I'm going to do is just do gray. I'm going to compare the P column, this guy right here, that guy, with the last column I just found, which is my actual comparison that I was looking for the entire time. And that color doesn't show up very well, so let's just go to plain old black. Because it's in disjunction, an or statement is my main comparison. I just need to make sure that one or the other is true, and I can write true down. So even though this is false, because the first part is true, in an or statement, I know as long as one part is true, I have a true value at the end. So I see a true right here, so that's true. I see a true right here, that guy's true. And remember, I'm comparing the P value with this guy. All right, I see true, true, false. Okay, well that's true as long as there's one true. Oh, false, false. That is my first false value. False, false again, another false. False, true, oh, true. And then finally false, false, false as well. Okay, so we finally have our truth values. Now, depending on what P, Q, and R are, and their truthfulness, if I said P was true, Q was false, and the statement R was true, I could look right away, and I could just look at this table. I'll highlight it for you. I'm looking for where P is true, Q is false, and R is, so true, false, true is what I'm looking for. So right here. If the statement P was true, the statement Q was false, and the statement R was true, then I would know that P or, so I would know this guy right here would be a true statement. A true disjunction. Its truth value would be true. Okay, I think you get the idea. So this is your introduction to truth tables, and I know you're going to come back with questions tomorrow. Don't worry, we're going to practice, but I want to introduce you so we at least have something to go off of when we get to class. So I'll see you tomorrow.